It all began with a stream of data, a faint whisper carried on the solar winds from the cosmic dark. A signal so subtle, it almost went unnoticed, lost in the background radiation of the universe. But it was there, persistent and undeniable, waiting to be discovered. In the sterile, brightly lit control rooms of the James Webb Space Telescope, hundreds of engineers and scientists, the culmination of decades of planning and work, held their breath. Scientists, their eyes glued to the monitors, watched with bated breath as numbers and graphs, lines of code and complex algorithms slowly revealed something utterly strange, something that defied all expectations, emanating from Proxima Centauri B, a world so close yet so impossibly far. Disbelief rippled through the room, quickly turning to frantic cross-checking. Was it a glitch? An error in the instruments? NASA and ESA teams, separated by oceans but united by a common goal, scrambled to find a mundane explanation, a simple answer to a complex question. But every test, every simulation, every conceivable error check came back negative. The data held firm. The signal was real, undeniably stable, and consistently coming from our nearest exoplanetary neighbor, Proxima Centauri B. It was a beacon in the dark. It wasn't just a new discovery, another dot on the map of the cosmos. It was a moment that shattered old maps of understanding, rewriting the textbooks in real time. The data, meticulously gathered and analyzed, showed a chemical fingerprint, a unique atmospheric signature in Proxima B's atmosphere that defied every known model of planetary formation and evolution. The world outside, bustling with its daily routines and concerns, remained completely oblivious, while a handful of scientists, burdened by the weight of their discovery, realized they might be holding the answer to humanity's oldest, most profound question: are we alone in this vast, silent universe? The James Webb Space Telescope, a marvel of engineering and human ingenuity, was painstakingly built for this very purpose: to peer into the swirling clouds and alien skies of distant worlds, and to search for the faint signatures of life beyond Earth. But no one, not even in their wildest dreams, expected its first, tentative look at Proxima B to reveal something so immediately, undeniably profound. In that single, earth-shattering moment, the universe, once a familiar and somewhat predictable place, suddenly felt infinitely stranger and infinitely more wondrous than ever before. Proxima B is the closest exoplanet to Earth, orbiting a red dwarf just over 4 light-years away. Its proximity makes it the best target for detailed study with current technology. Located in the habitable zone, it could have liquid water, key for life as we know it. But Proxima B is likely tidally locked, with one side in perpetual day and the other in endless night. The twilight terminator zone might be just right for life, but violent stellar flares threaten its atmosphere. Proxima B is a cosmic test case, a rocky world in the habitable zone, facing immense challenges. Whether it's thriving or barren, what we learn here could reshape our understanding of life in the universe. The James Webb Space Telescope, our most advanced space observatory, is designed to peer deeper into the universe than ever before. It acts as a cosmic detective, gathering clues from the light emitted by distant stars and planets, allowing it to analyze the composition of celestial objects. One technique is using transmission spectroscopy to analyze exoplanet atmospheres. By studying how starlight filters through a planet's atmosphere as it passes in front of its star, Webb can identify the gases present. For Proxima B, the closest exoplanet, the challenge was immense. It doesn't transit its star, meaning we can't use transmission spectroscopy, making atmospheric analysis difficult. So, scientists used Webb's coronagraph to block the star's glare, creating an artificial eclipse. This allowed them to isolate and capture the planet's faint thermal glow. The primary goal was to detect any atmosphere at all, crucial for habitability. Then the next step was to search for biosignatures, chemical indicators that might suggest the presence of life. Scientists then compared the collected data to sophisticated computer models, representing both barren, rocky worlds and potentially habitable living worlds. The ultimate hope was to catch a glimpse of the air of another world, to peer into an alien sky and understand its secrets. The question of Proxima B's atmosphere hung in the balance. This was humanity's first truly ambitious attempt to decipher the atmospheric composition of a planet orbiting another star. The data came in, and the analysis stunned everyone. Webb detected something extraordinary using its infrared capabilities. Instead of typical biosignatures, Webb discovered a thick haze of chlorofluorocarbons, or CFCs, in Proxima B's atmosphere. On Earth, CFCs are industrial pollutants that have damaged our ozone layer. These compounds are created only by advanced technology and complex industrial processes. There are no known natural processes that could produce them in such quantities as detected on Proxima B. The spectral signature was unmistakable. It was a chemical billboard, broadcasting its presence. This wasn't just a hint of life. It was direct evidence of industry on another world. It pointed to a civilization capable of actively altering its planet's chemistry. The discovery leapfrogged the question, "Are we alone?" and propelled us to, "Who are our neighbors, and what are they doing?" The presence of CFCs on Proxima B is a shocking sign of a technological civilization. The silence of the cosmos was suddenly broken. It was the inadvertent chemical echo of industry. The implications of this discovery are staggering. It forces us to confront the reality of another technological presence. The universe just got a whole lot more interesting. The detection of industrial pollutants on Proxima B is both thrilling and deeply unsettling. It could mean a thriving civilization, or the chemical tombstone of one that destroyed itself. On Earth, CFCs nearly caused an environmental catastrophe before we acted. Is Proxima B's haze a sign of a young, reckless industry, or the aftermath of collapse? This discovery raises the specter of the Great Filter, the idea that civilizations may self-destruct before reaching the stars. The data is a cosmic mirror, reflecting our own environmental challenges and future. The question is no longer just, are they there, but what happened to them, and could it happen to us? Or should we be worried? Not about a direct threat. Proxima B is over 4 light-years away. The real concern is existential. The discovery is a warning and a lesson. If the CFCs mark a civilization's downfall, it's a glimpse of what could await us if we fail to manage our technology. If they're from a thriving society, it's a beacon of hope that survival is possible. Either way, the discovery forces us to reflect on our own choices and future. The laws of nature are universal. The consequences of ignoring them may be too. This is a wake-up call on a galactic scale. The story of Proxima B is, ultimately, a story about us. Or this is just the beginning. Scientists will reconfirm Webb's findings and search for more clues. New telescopes both in space and on Earth will focus on Proxima B, hunting for more chemical signatures and possible radio signals. SETI efforts will intensify listening for any sign of communication. Ambitious projects like Breakthrough Starshot may one day send probes to Proxima Centauri, bringing us close-up images within a generation. The discovery unites us in wonder and drives innovation. Whether Proxima B's story is one of triumph or tragedy, it challenges us to become better stewards of our own world. The universe is vast and mysterious. Our journey has just begun. We must keep looking up, asking bold questions, and exploring with courage and wisdom.